Dear students, today we are gonna solve these problems on our second tutorial session. So first it is problem number 4. As you can see, we're gonna what we have it is productivity, which is equals to 1. Also we have marginal product of labor, which is given by this formula. First of all, we also have nominal wage equals to $10, and what we need to find is a real wage, and we can do it by the formula the nominal wage divided by the price of output. And after the mathematical manipulation we will have 5. So our real wage equals to $5. Then we can find the number of labor hours by this formula, and we will get 95. So as you can see in the graph, when we have 95 number of labor hours, then our real wage will be $5. Okay, this will be the equilibrium real wage. So now we will look at the nominal wage equals to $20. In this situation, yes, there we will have real wage equals to 10, and our number of labor hours will be 90. And also we can see it on the graph, and we will have 2 points. And we will get the demand curve for labor, which is downward sloping curve. Let's move on, and we will look at B sub question, and there what if we will have productivity equals to 2, then equals to 2, then we will have the same indicators, and there we will have wage equals to the 5, and number of labor hours will be equal to 97.5, and at the nominal wage equals to 20, we will have real wage equals to 10, and the number of labor hours will be equal to 95. Then we are plotting the graph. So when we have 5 real wage, then our number of labor will be 97.5, and when the real wage equals to $10, then our number of labor will be 95. Then we plot the diagram, demand curve for labor. Okay, numerical problem number 7. What we have? We have labor force equals to 500 people, and we've got every month 5 people lose their jobs. Yes, every month 5 people lose their jobs for 1 month, and every 6 months 20 people are unemployed. Yes, according to the text of the problem. 20 people lose their jobs and remain unemployed for 6 months before finding the new jobs. So we can construct it like that, and every month there is 5 people who are unemployed, and every 6 months there are 20 people who are unemployed. So total we have at any date 25 people are unemployed. So our unemployment rate is 25 divided by 500, which is 5%. Okay, what about the fraction of unemployment? So it is a B-sub question. Each month, 5 people have 1 month spells, and every 6 months, 20 people have 6 month spells. So the total number of spells during the year is we can find it by this equation, where we will multiply 5 by 12 and plus 20 multiplied by 2, because we have in the whole year we have only 2 spells for 20 people and 12 spells for 5 people. So then we will have 60% lasts 1 month and 44% of spells last 6 months. Okay, what about the sub-question C? What is the average duration of a completed spell of unemployment? There we have 0.6 unit. We multiply for 1 month, yes, because we have 60% of spells which is lasts 1 month, and 40% which is 0.4 which is last 6 months. Then we will have 3 months. The average duration of completed spell of unemployment is 3 months. Okay, what about the fraction of unemployment? As I said before, on any given date, there are 25 people unemployed. 20 of them, which is 80%, have long spells of unemployment, while 5 of them, 20%, have short spells. Let's consider first analytical problem, where we have increasing of productivity by 10%, and where we will have to show how this change affects the graphs of both production function relating output to capital, which is this graph, and production function relating output to labor. Okay. In the initial situation, capital and labor N produce output Y. When productivity rises, they produce output 1.1 Y. Suppose that a small increase in capital to K2 with labor left at N1 produce output Y2 in the initial situation. Then it produces 1.1 Y2. To make it clear, we can write the production function, which is Y equals to AF and N, yes, which is amount of output produced to quantities of capital and labor utilized. Okay, then if we raise productivity to 0.1, it means 10%, then we will have new production function. Let's say it's Y2, which equals to 1.1 AF K or N. So you can see it on this graph here. This is our initial production function, and after the changes we will have new production function, which is Y equals to 1.1 AF K. Then we also can write this like 1.1 Y. Yes. If we indicate it like 1 Y1, there will also be 1. So after that we can see that our productivity, our production function also rises. Okay, let's solve this through the marginal product of capital. As we know, it is marginal product of capital is increase in output produced that results from a 1 unit increase in the capital stock, which is delta y divided by delta k. When productivity rises, the new MPK is 1.1 y2 minus 1.1 y1, yes? This is divided to the changes in capital. So we will have, this equation, and after that we will have 1.1 MPK, which means that the new MPK rises to 10%. So this argument is completely symmetric. So it holds for marginal product of labor also, as well. If you substitute N for K everywhere and follow the same steps, you will show that the new MPN is 10% higher than the old MPN. Regarding the subquestion C, yes, it is possible for beneficial productivity shock to leave the MPK and MPN unchanged. This could happen only if the shock was additive, that is, if it shifted the whole production function upward, but did not affect its slope at any point. So you can see there as a shift up in the production function, leaving the slope unchanged. Okay, let's talk about the question 2, where we have to explain changes of the current level of full employment output after several factors. First of all, this is a large number of immigrants into the country. And increasing the number of immigrants increases the labor force, increasing employment and increasing full employment output. So what about the energy supplies become depleted? If energy supplies become depleted, this is likely to reduce productivity because energy is a factor of production. That is why our production function will go down. Better education in subquestion C rises future productivity and output, but has no effect on current full employment output because it is long-term activity. A new law mandates the shutdown of some unsafe forms of capital. This reduction in the capital stock reduces full employment output, although it may very well increase welfare. Continue our session. Now we are gonna look at problem number 6 of the chapter 4. What we need to find? We need to find desired national saving. Full employment output and government purchases are given. Also, consumption, desired consumption and desired investment are also given as equation. To solve this problem, we're going to use definition of national saving, which is SD equals to Y minus consumption, desired consumption minus government spending. So after that, we will put all known figures, and so as you can see, we just replaced desired consumption with the formula that was given, and we will get the equation of desired national saving. What about the subquestion B? There we have to find the real interest rate that clears the goods market. To do so, we're again refer to the definition of national saving. We just transform it, and we will get we will get real interest rate. There we have to assume that output equals full employment output. So at full employment output at 6,000, we can solve real interest rate. We also can solve this problem by using another equation, and we also have all the figures and amounts, and we will have the same R as in previous attempt. Equation C, we have to show the change of equation when we are inserting government purchases. Yes, when purchases rises to 1,440. So in this case, again, recalculate the desired saving, and it becomes this way, this equation, and we can just compare with the previous one, which is this one, and we can see that there is the difference only 240. The second equation is less for 240. So we can also show it in the graph. And we can see that the desired national savings line shifts up, which lead to decreasing of the desired savings from 800 to 640. And using the desired national savings equals to desired investment equation, we can calculate real interest rate. There we have to mention that the output equals full employment output, as the problem sets. So as a result, we will get the market clearing real interest rate increases from 10% to 14%. Okay, and now we're gonna look at problem number 9, and there we have the consumer who have 3 periods: learning period, working period, and retirement period. Due to this time, her income was different, and what we need to calculate is consumption and saving in each period, assuming no borrowing constraints. And what happens if the consumer faces borrowing constraint? Okay, first of all, we will look at the present value of lifetime resources. This is the value of income that consumer expects to receive in current and future periods, and plus initial wealth. So there is some abbreviations like PVLR, PVLS, and this is present value of lifetime consumption, YLCL, SL, output, consumption, and savings of the learning period, and the same for the working period and the retiring periods. YF, this is a future output, and A, this is initial wealth. So we will look at the equation of the present value of lifetime resources. Yes. First of all, we have to calculate all consumers' inputs, all consumers' revenue. So what we have the 200 income on the learning period, 800 during the working period and 200 during the retirement period. And overall it is 1,200 plus initial assets like 300. And overall we have 1,500 dollars for the whole period. And after that, to calculate her consumption, we need to take in mind that the consumption, present value of lifetime consumption is equal to the present value of lifetime resources. So after the calculation, we will have that for each period, her consumption should be equal, and it is equal to the 500. Yeah, we did it by the dividing 1,500 to 3, because we have the 3 periods and we have the 3 consumption. Okay, if this is clear, then we will look at saving. To calculate saving of each period, we have to subtract from the income her consumption. So at the learning period, she earns 200 and minus 500. As consumption, there is minus 300. And for the working period, it's plus 300, and for the retirement, it's again minus 300. In this situation, we are not need borrowing constraint, because at the learning period, we also have the initial wealth as 300. So we have 300 initial wealth plus her earnings like 200, which is 500, which is equal to the consumption. So, and for the working period, it's her earnings exceed her consumption. It's also okay. And for the retirement, the excess that is remain from her working period will cover her consumption. That is why a borrowing constraint is non-binding. However, if we look at the second sub-question, where consumers' initial wealth is 0 instead of 300, then the present value of lifetime resources will be lower, and it equals to 1,200. There is the no borrowing constraint. The consumption will be equals to 400 for each period. From this point of view, we can say that savings at learning period is minus 200. Working period, it is 400, and at retirement, during the retirement, it's minus 200. However, at this time, the borrowing constraint is binding, because her earnings and her earnings only $200 without any additional welfare, but the consumption is 400. That is why the consumption is exceed her earnings. So it is constrained to be 200. But for remain 2 periods, it is okay, because their consumption will be 500, and their output is exceed their consumption. And after the borrowing constraint, we can see the savings changed. Consumption can be lower in all periods due to a binding borrowing constraint, because the present value of lifetime consumption must be the same with and without borrowing constraints. Now we are going to analytical problem number 4, chapter 4. There we see that government purchases temporarily increased, and we have to illustrate the changes through the diagram. If we increase the government spending, then our savings will decrease. And that is why our saving curve shifts up. As we can see on the graph from equilibrium point, the savings will decrease, and after that, to reach as savings equals to investments, which will give us the new equilibrium point, we will have to raise our real interest rate. And after that, we can see that our investments also decreased to that point, and there is our new equilibrium point, which reduces national saving. Okay, what about the question, does it matter whether the temporary increase in military spending is funded by taxes or by borrowing? No, there is no difference because spending is financed by current taxes or by borrowings, and rising the borrowings will lead to the rising the future taxes. That is why it is not so big difference. Let's take a look to another case where our spending is for infrastructure. So marginal product of capital rises, so investment increases, which lead to shifts investment curve to the right. Although it is still spending, that is why our saving curve also shifts to the left, and we will have new equilibrium point. So with upward shifts in both saving and investment, the new equilibrium point is one with a higher real interest rate. However, saving and investment at the new equilibrium may be higher or lower. Real interest rate affects for both lines, so it is so the effect on consumption is unclear as well. The higher real interest rate reduces consumption, but future income is higher, which increases consumption. If we suppose that in this case investment actually rises, then the government spending will be cause of crowded in of private investment, and in this case the consumption will be crowded out.